So final block is a method which is called upon the call to the finish, dollar finish inside the program block. And it
No,
is
no, no.
used
Can you
to
repeat? Hold on. Can you repeat, please? I did not get that.
So final block will get executed when there is an like implicit call to the dollar finish. It automatically called by the simulator. It is used to print the information. What can I say? That the information at last.
Final block. Final block is similar to initial block. Okay. How does it work? It gets executed only and only when it is very, very important. Only and only when there is an implicit or explicit call to dollar finish. Who is the hero of the story here? Dollar finish.
Finish.
If there is no call to dollar finish, this will not get executed. Is that clear? Manshi?
Final block also working in module also.
Yes.
So what why you said automatically called so that we can use dollar finish also?
No, when you okay. Where to use, what is the difference between implicit and explicit? If let's say you are in module, as I said, if you have initial block, there is a definitive start and definitive end in there, correct? Now we can have multiple initial blocks, one initial block, two initial block, three initial blocks. Then the important aspect of this is when we talk about always block. Now if I have always block, is there a definitive start and end to always block? As the name says, it is always. It will keep running. It will keep on running. Right? Forever. So can module automatically decide when the simulation starts and finishes? It cannot. That is the reason the construct that will help you in module is $finish. So in any one of these, initial, begin, end, whenever you are done driving the simulation from the test bench, you make a call to $finish. The moment simulator sees $finish, what it will do, it will go ahead and look for all the final blocks in the system. It will go ahead and look for all the final blocks in the system. Final, begin, end. All the final blocks will get executed only when the simulator encounters $finish. The simulator executes this. That is the explicit. So whatever I just explained is explicit call to $finish. From where does it happen? It happens from within the module. From where does it happen? It happens from within the module. Is this clear so far? Now,
yes.
The next thing. What is implicit call now? Then, what is implicit call? Implicit call is when we are in program block. Back to red. Implicit call is in when we are in program block. What is program block? Program block is similar to module, but there are few obvious differences. That is, it executes in the reactive as opposed to active, where the module executes. What is the other difference? The very important syntactical difference is that always block is not allowed inside program block. You cannot have an always block. Because you cannot have an always block, you have only initial, begin, end. Then it is a calculated approach by the simulator where it can predict when the simulation ends. Because if the simulator executes all the initial blocks and there is no always block, then it knows at the end of all of the initial blocks the simulation has to finish. That is the reason it can automatically call $finish. You don't see it in the code because there is an automatic call to $finish. Again, final block will get executed. That is the reason either there is an implicit call, which is this red implicit program. Towards the end, it can automatically call. There is a final begin it getting executed. Or if you find yourself in the module, then you have to trace your routes where you have to explicitly add a code based upon a condition where $finish gets executed, and only then you will see that the final block will get executed. So what are the conditions for final block to get executed? Either there is an implicit or an explicit call to $finish. Now, the next aspect of this discussion, that is if there are multiple final blocks, how will they get executed? So it comes back to the question first. If there are multiple initial blocks, how will they get executed? All initial blocks will get executed parallelly. But that is not the story with the final block. So let me ask you guys, how does a final block execute then if there are multiple final blocks?
Based on the
it is based upon the
not predict.
Yes. So based upon the simulator, it will get executed. So it is executed in serial order, not parallel. This serial order is dependent upon the simulator. Either it is VCS or Cadence or Mentor Graphics is Questa. Based upon this simulator, they can define any order. Then if the order is not definitive, will that not cause any problems to us? No, it won't. Why? You have to understand the next point or a point before that. Why serial order? What are the things that executes serially? The things that execute serially are the things that do not consume time. Like in UVM, all of your phases which are functions get executed serially, right? Either top down or bottom up. Run phase is the only phase which runs in parallel because there is time consuming, it is task. In the same way, initial block, it works in parallel. Why? Because you can have delays. It can consume time. Always block runs in parallel. Why? Because it consumes time. You cannot stack them one after another. Because if one always block is running and the other always blocks are not running, then it is a problem, right? You want multiple always blocks to run in parallel. You want multiple initial blocks to run in parallel. But in the same way, you do not expect to have the same expectations from final block. Why? Because final block does not allow delays. You cannot have delays in your final block. Because you cannot have delays in your final block, they can execute in serial order. Now, why you cannot have delays in the final block and it is still okay? Is because you have to understand what is the purpose of final block. The purpose of final block is statistics. That's it. Print statistical information. What it is? Number of matches and mismatches in the scoreboard, right? Number of transactions driven in the test case. Just meant for statistical printing by the test bench. Program block is for the test bench. Final block mostly for the test bench, but you can also use it in the module. So what are the important points that you need to know about the final block? The points that you need to know about the final block are: first, it is executed when there is an implicit or explicit call made to $finish. You can have multiple final blocks, they all get executed serially in an order which is dependent upon the simulator. How can it execute serially? Because there are no delays allowed in the final block. Why there are no delays allowed in the final block? Because it is not meant to be used in a fashion where delays are needed. It is meant to be used only for display purposes. This is everything that you need to know about final block in a nutshell. Okay. Now, why I introduced final block to you guys? Why did I introduce final block to you guys? The reason I introduced final block to you guys is because I wanted to start a discussion on program block. On program block, we have so far made a note that one syntax oriented rule we got to know that always block is not allowed. And the advantage of having that is there is an automatic call to $finish. There are obvious advantages when you get some things, right? The advantage is that always block is not allowed, and the advantage of that is that automatically there is a call to $finish. What are the other syntaxes that we need to know about program block? Program block, you cannot instantiate another program block. You cannot instantiate interface. You cannot instantiate module. Basically, you cannot instantiate anything in program block. The other way around is possible. That is, a module can instantiate another module. A module can instantiate interface. A module can instantiate program block. So it is okay for the module, but it is not okay for the program block. This is another syntax. And one more syntactical rule about the program block that you need to know is all the non-program block variables should use non-blocking assignment. All the program block variables should use blocking assignments, because when you use blocking assignment, they get executed in reactive region. All the non-program block variables will get executed in re-NBA region. What do you mean by non-program block variables? Every program block will have obvious inputs and outputs and some local variables. Now in this one, the category that we are looking for is non-program block variables. What comprise of non-program block variables? Only the outputs or any reference to module or other variables which are outside of the program block will comprise of non-program block variables. What are program block variables then? All the inputs and all the local variables are program block variables. So we call them program block variables. And all the outputs and the variables that come from outside the program block are non-program block variables. These are the syntaxes that you need to know when it comes to program block. Now, but we have not yet had a clean introduction to program block yet, right? So what would be the introduction to program block? What would be the introduction to program block? These are syntaxes. Syntaxes are all fine, but what is an introduction to program block?
When you verify that key design, if you use the module initial block, an example, I'm writing the assign statement with the design. Assign A is equal to Y, example. And the PB side of the same zero time, I'm doing the Y is equal to in between the race condition.
The introduction to the program block goes like this. There is point number 0, which is very important. It is an entry point into test bench. With that said, what does it mean? That means program block is for test bench only. Now, what is the advantage of using a program block? It avoids the race condition between design and test bench. It avoids the race condition. How it does that? By executing in re. There are all these regions, right? Reactive, re-inactive, and re-NBA. This is a completely different set, correct? This set gets executed after. After what? Yes. After our active.
After active, inactive.
Inactive. NBA. and observed region. Observed region is for assertions, program block. There is a bit of an overlap there. Okay. So first dollar monitor. Okay. So what was I saying? This is therefore the right hand side part is specifically only for module, that is active, inactive, NBA, observed. The second block that executes after, that is reactive, reinactive, and re-NBA. Oh, instead of NBA I wrote RBA. No one corrected me. This is for program block only. Okay. Now after this there is one more region that is very special. Okay, that is called as a postpone region. And before this there is a one very special region called as prepone region. There is a certain specifics that you need to know about what is this prepone and postpone region. I am purposely drawing this in a different color. What is that specifics that you need to know is that they are overlapped. How to visualize the overlapping nature is via following this color. Okay, so no, let me not use a color but a shape to explain that. Let's say this is your first region of simulation. Okay, then this is your, let's say, second region of simulation. Okay, this is how it literally works in the simulator. This region is not 2 but 1, the shaded region in between. How it works is, for the, if you are looking at this guy, let's say this is your current timestamp, this will act as a pre. But if let's say you are looking at this guy, this will act as post. So they are like overlapped. Okay, successively if you keep on going, right, they are a bit overlapped with one another like this. Continue, they are continuously overlapping one another. They are continuously overlapping one another like this. Understood? What do you mean by pre and post are overlapped? For the current timestamp, it works as a pre, but for the previous timestamp, it was a post. So these are not two separate, but one. Okay? Got it? Any doubts, any concerns, guys? So how many regions of simulation are there in system Verilog? Shailaja? In summary, quickly, guys, how many regions of simulation we have in system Verilog? 8. Sure.
8.
9. Count. It's on.
Yes.
So, what is program block? Program block is an entry point into test bench. It helps avoid the race condition between design and test bench. How it does that? By executing in reactive, reinactive, re-NBA region. And these are the new regions that got added in system Verilog. Pre and post is overlapping between successive timestamps. Okay? And Reactive, reinactive, re-NB is where program block executes. Hence, it avoids the race condition between the design, because design executes first, then the program block executes. What are the different ways system Verilog gives syntaxes or constructs to avoid this race condition that I'm talking about between the design and test bench if someone asks? First one is program block. The second one is clocking block. See, in Verilog, the first one is active inactive. Verilog tried to solve that with active inactive. Then it was not super successful. We went to system Verilog. In system Verilog, it's all tried to solve it with reactive, reinactive, re-NBA. Still, it's not. There are obviously some issues with it. Then the best solution put forward was a clocking block. Clocking block helps us avoid all these race conditions that I'm talking about. How it does that? See, for every statement, you should also try to justify it. How it does that? By giving skews. What are skew? Input skew and output skew. Input skew is a sampling point before the edge of the clock. Output skew is after the edge of the clock. We'll discuss that in detail tomorrow. Okay, with interfaces and virtual interfaces. But this is a quick intro into what is a program block and a final block. Any doubts, any concerns, guys?